here we have two functions, y equals f of x and y equals negative f of x. And in general, the graph of y equals negative f of x is a reflection of the graph of y equals f of x in the x-axis. And what this means is that when we move all of y equals fx, so when we move all the points of y equals fx and we reflect them in the x-axis, we will get the function y equals negative f of x. So here we have two functions, fx equals 2 to the power of x and fx equals negative 2 to the power of x. And if we see here, guys, the red function, if reflected in the x-axis, will create the blue function. And we can write the mapping notation of this transformation as x comma y to x comma negative y, because all of these points on the red graph got reflected in the x-axis, and what that means is that their y values all turn into a negative value. So for example, this point right here is 1 comma 2, but if we reflect it in the x-axis, we will get to this point, which is 1 and negative 2. So our y value just got a minus sign added to it. So when we reflect this function in the x-axis, we get this function because we put a negative sign in the function, and our mapping notation will be x comma negative y, because if we reflect the function in the x-axis, we move all their points and we give their y values a negative sign. So in summary, the graph of y equals negative f of x is a reflection of the graph of y equals f of x in the x-axis. And if we reflect the function in the x-axis, we change all their points y value into a negative value. So for example, if the point 1 comma 3 is on f of x, if we write the corresponding point that's on the graph of negative f of x, that will be 1 comma negative 3. And if there's a point of 2 comma negative 3, the corresponding point here will be 2 comma 3. So we just add negative values or negative signs into the y values of y equals f of x.